Well, in the last video, we went all the way through example number 2 and dealt with a lot of questions that had x approaching negative or positive infinity. And at this very last example, we came across what we would call a polynomial function. Specifically here, it was a quadratic function. And we saw that we had a limit that went towards infinity. Now, this particular example can lead us to an important observation. Take a look here. When we are computing the limit specifically for a polynomial as x approaches an infinity or a negative infinity, what's really going to matter, what's really going to determine the result of that limit is actually going to be the highest power term. That is, the term with the highest degree, okay? Or the highest exponent. So in this case, you can kind of get the sense of what we're talking about. Notice here that if I was to plug in very small values of x, I can see that taking a small value of x and squaring it can make a slightly bigger number, right? Like if I took 3 and I squared it, I'm going to get up to 9. But if I took 20 times 3, that's 60. And so this negative 60 that's going to be produced here is going to be much more dominant than this positive 9. And so I can see that in the small term, this middle, or in the short term, or for small values of x, this middle term kind of dominates or controls what this function is going to do, whether it's going to be spitting out negative values or positive values. But notice that immediately as x begins to get really large, the fact that I'm squaring a value becomes so much more influential or impactful to determining the size of the overall results of this function. Notice if I plug in 100, 100 times 100, well, that's going to be something, right? 100 times 100 is going to have 4 zeros after it, so that's going to be 10,000. Whereas if I take 20 times 100, that's only going to be 2,000. So notice that even by the time I get up to 100, this first term is totally dominating all of the rest and will really influence the overall result. So it's because of this that we say, when we're computing the limit of a polynomial, we really only need to consider what happens to the largest powered term if x is going towards negative or positive infinity. So take a look here at something like example number 3. Here it looks like I have a lot of complicated things that are going to be happening. But this is actually a really, really simple question to answer, because I'll notice right away this is a polynomial. And while this first thing here is going to be, let's see, if x is approaching negative infinity, then notice I'm going to have a negative number in there. It's going to be cubed, so it's still going to be negative. This first item in here is going to be negative. This next item would be positive since it's squared, and the last item is going to be negative again. So notice here I'm going to have something that's kind of like a whole bunch of different values added or subtracted together, and sometimes it might even be confusing trying to figure out if the result's negative or positive. But if I use the fact from up above, I can see that the only term here that actually matters is the one with the highest power. So really, I can take this and turn it into a limit as x approaches negative infinity of 7x to the third. And now I can just think about what's going to happen directly with this. Notice if I was plugging in again a negative value for x, which is the types of values that I'm moving towards, then the overall result that I would get out of here is going to certainly be negative, because a negative number cubed times a 7 produces still a negative number. And if the number I'm plugging in is becoming unbelievably large, just in a negative direction, then when I take that value and I cube it and then multiply by 7, it's going to only continue to get larger and larger and larger as the input gets larger. So this is a really easy way that I can see here that this graph also has no horizontal asymptotes, at least in this direction. Right? And I can see here that my limit comes out as negative infinity.